Spring 1942, Fort Knox, Kentucky. Two engineers stood 8 miles apart, each holding a prototype radio that would change battlefield communications forever. Daniel Noble, director of research at Galvin Manufacturing Corporation, pressed the transmit button on his prototype and spoke into the handset. His voice, crystal clear and free of static, traveled through the air using frequency modulation technology. 8 miles away, his colleague Henry McNusky heard every word with perfect clarity. The Army had specified a minimum range of 3 miles. Noble's team had just demonstrated more than double that distance in prototype testing. What made this achievement even more remarkable was that the Army had initially mandated amplitude modulation AM technology for all portable radios. Noble had convinced them to gamble on frequency modulation FM instead, arguing that AM was fundamentally unsuited for battlefield communications. That gamble was about to pay off in ways that would help win World War II. The 300 Seychelles rupees walkie-talkie they were testing would provide reliable communications, over 3 miles in operational use with up to 5 mi, possible in optimal conditions. This represented a threefold improvement over existing handheld infantry radios and would give American troops a communication advantage so overwhelming that one general would later declare it the single most useful piece of communications equipment employed in the European theater. This is the story of how one engineer's insistence on superior radio technology revolutionized battlefield communications and contributed materially to Allied victory. The journey to that breakthrough moment in Kentucky began in September 1940 when Daniel Earl Noble walked through the doors of Galvin Manufacturing Corporation in Chicago as Director of Research. Born on October 4, 1901 in Norristown, Connecticut, Noble had earned his engineering degree from the University of Connecticut and made his name by designing the nation's first statewide two-way FM radio communications system for the Connecticut State Police. Completed in 1940, he understood what FM could do: noise rejection, clarity, and reliability in the presence of electrical interference that crippled AM systems. Noble arrived at Galvin Manufacturing at a pivotal moment in American history. War had engulfed Europe. France had fallen to Nazi Germany in June 1940. Britain stood alone against the Third Reich enduring the Blitz, while the Royal Air Force fought the Battle of Britain. Though America remained officially neutral, military involvement seemed inevitable to anyone paying attention. President Roosevelt had begun the military buildup that would accelerate dramatically over the next year. The Army was scrambling to modernize equipment, doctrine, and training for a war that would be fought on a scale no one had fully imagined. Among the many deficiencies the military faced, battlefield communications ranked among the most critical. Modern warfare required coordination across unprecedented distances and among unprecedented numbers of units. Infantry squads needed reliable ways to communicate with company and battalion headquarters. Forward observers needed to call in artillery fire with precision and speed. Tank commanders needed to coordinate with infantry support. Commanders at every level needed to maintain situational awareness and issue orders rapidly as tactical situations evolved. But the radios available in 1940 were woefully inadequate for these demands. The Army had experimented with portable infantry radios in the late 1930s. The 190 for Seychelles rupees and SCR-195 had been attempts to give infantrymen portable communications. But these early efforts had been dismal failures. They used primitive super-regenerative circuits that were temperamental at best and completely unreliable at worst. They operated on AM frequencies, which meant every electrical motor, every vehicle engine, every thunderstorm. Every piece of electrical equipment generated static and interference that drowned out vital communications. The radios were so unreliable that infantry officers had grown deeply cynical about radio communications in general. Many preferred to rely on runners carrying messages by hand, even though runners could be killed or wounded. Even though messages might arrive too late to affect the tactical situation, at least runners were reliable when radios were not. Galvin Manufacturing had already achieved some success in military communications with their handheld radio, the SCR-536, nicknamed the Handy Talkie. Don Mitchell, Galvin's chief engineer, had driven that development, and the Army had been impressed enough to award the company a production contract. President Franklin Roosevelt's Secret Service was reportedly using the Handy Talkie to protect the president even before Pearl Harbor brought America into the war. The SCR-536 represented genuine innovation for its time. It was compact, truly handheld with the microphone, earphone, batteries, and antenna all integrated into a single 5.1 to be case that a soldier could operate with one hand. It operated on high-frequency AM from 3,500 to 6,000 kilohertz and was crystal-controlled for frequency stability, which was an improvement over earlier designs. But the SCR-536 had one crippling limitation that no amount of engineering refinement could overcome within its basic design parameters. Its maximum effective range was approximately 1 mile under good conditions. That might work adequately for communications within a platoon, between squad leaders and their platoon sergeant, or between a company commander and his platoon leaders if they stayed relatively close together. But it was completely useless for anything beyond that limited range. Infantry companies couldn't talk to battalion headquarters several miles to the rear. Forward observers couldn't direct artillery fire from observation posts miles away from the batteries they were supporting. Tank platoon couldn't coordinate with infantry companies during combined arms operations. The 1M range of the SCR-536 made it a useful tool for tactical communications at the very lowest level. But it left a gaping hole in the military's ability to command and control forces across the distances that modern mobile warfare required. Shortly after Noble joined Galvin Manufacturing in September 1940, he accompanied Don Mitchell to Fort Monmouth, New Jersey to present the Handy Talkie to the Army Signal Corps for evaluation. Among the Signal Corps officers present that day were two men who would play crucial roles in the development of longer-range portable radio communications. Colonel Roger B. Colton, who had been director of Signal Corps Laboratories since 1938, and Major James Dunn O'Connell, who served as executive officer of the laboratories and would soon be heading radio communications projects. The Signal Corps officers were pleased with the Handykie's performance and design, but they made clear to Noble and Mitchell that they needed something more, something with substantially greater range that could still be carried and operated by an infantryman in combat. The Army needed a portable radio that could bridge the gap between company and battalion, that could reach back 5 or even 10 miles to higher headquarters, that could function in the electromagnetically noisy environment of modern mechanized warfare. In 1940, facing this requirement, the Signal Corps contracted for development of a new portable AM transmitter receiver. The decision to specify AM technology was understandable given the military's experience and infrastructure. AM was established, proven technology. The military knew AM, trusted AM, had built its entire communications infrastructure around AM. Military radio operators were trained on AM equipment. Maintenance personnel knew how to repair AM radios. The logistics system was designed to support AM equipment. AM was the safe, conservative choice for a military organization that valued reliability and maintainability. When Noble learned of this decision during meetings in Washington, his response was immediate, forceful, and risky. He told Major O'Connell that contracting for an AM portable radio was a grave mistake. The area of development, Noble insisted, should be for an FM portable unit. This was an extraordinarily bold stance to take with military procurement officials. Noble was essentially telling the Signal Corps that they were making a fundamental error in their technical approach. He was contradicting the military establishment's preferred technology. He was advocating for a more complex and potentially more expensive solution. He was asking the Signal Corps to take a chance on a technology that many radio engineers considered impractical for portable military applications. AM was familiar. FM was exotic, newer, less proven in military applications. FM required wider bandwidth than AM, which meant fewer channels could fit in any given frequency allocation. In an era when radio spectrum was already considered a scarce and precious resource, that bandwidth requirement seemed like a serious drawback that might outweigh any potential advantages. FM circuitry was more complex than AM, which raised concerns about reliability in field conditions and the ability of military maintenance personnel to keep the equipment operational. FM transmitters and receivers required more sophisticated components and more precise tuning mechanisms than their AM counterparts. But Noble understood something that many radio engineers of the era did not fully appreciate. He understood that FM offered genuine fundamental advantages that would more than outweigh its complexity and cost in battlefield applications. FM inherently rejected electrical interference and noise in ways that AM simply could not. FM provided clear voice transmission even at the limits of its range, while AM signals faded into progressively worse static and noise as range increased. FM would work in the electromagnetically hostile environment of a battlefield near running vehicle engines and electrical equipment in conditions that would render AM radios nearly useless. Noble had seen this demonstrated in his Connecticut State Police FM system, where FM radios maintained clear communications in conditions where AM would have failed. Noble's conviction about FM's superiority, combined with his proven track record and his technical expertise, carried the day. Major O'Connell, convinced by Noble's passionate and technically grounded arguments, issued a Signal Corps contract for development of an FM portable transmitter receiver to Galvin Manufacturing Corporation. The designation assigned to this new radio would be 300 Seychelles rupees. Signal Corps radio number 300 with that contract. Noble and his team embarked on one of the most challenging and ultimately most successful engineering projects of World War II, back in Chicago. Noble moved quickly to assemble his engineering team. The core group would consist of some of the brightest minds Galvin Manufacturing could field. Henry McNusky, who had immigrated from Poland and would become one of the company's most distinguished engineers, would serve as principal RF engineer, the man responsible for designing the critical radio frequency circuits that would make or break the entire project. Marion Bond, Lloyd Morris, and Bill Vogel rounded out the core team, each bringing specialized expertise in different aspects of radio design and development. They would need every ounce of that combined expertise and experience because the Army's specifications for the 300 Seychelles rupees were extraordinarily demanding. The 300 Seychelles rupees had to be battery-powered with sufficient energy capacity to operate for useful periods in the field without requiring frequent battery changes. It had to weigh no more than 35 pounds, complete with batteries and accessories, light enough for an infantryman to carry on his back for extended periods while still being able to fight when necessary. It had to provide reliable communications over a distance of at least 3 miles in varying terrain, through forests and over hills, in conditions far more challenging than line-of-sight transmission. It had to be water-resistant, able to withstand rain and the general moisture and humidity of field conditions without failing. It had to be simple enough for soldiers with minimal technical training to operate effectively under the stress and confusion of combat. It had to tune across a range of frequencies from 40 to 48 mega, providing multiple channels so that different units could operate without interfering with each other. And critically, given wartime production constraints, it had to use only to frequency control crystals, because crystal production was a bottleneck that would become increasingly critical as war production ramped up across all types of radio equipment. Meeting all these specifications simultaneously seemed almost impossible. Each requirement by itself was challenging. Taken together, they represented an engineering puzzle of extraordinary difficulty. But Noble's team had one enormous advantage that made the seemingly impossible merely very difficult. They were using FM technology, and FM's inherent characteristics would help them solve several of the most challenging problems. One morning in late 1940, soon after Noble had formed his team and received the official contract, he approached Henry Mignowski and Andy Affronti, a young engineer who had just started working in the research laboratory. Noble asked them to sit at Affronti's workbench, motioning Mignowski to sit at his right and Affronti at his left. He placed an official-looking sheet of paper on the bench between them. Affronti noticed the formal heading that read United States Army Signal Corps. Noble read the 8 paragraphed items aloud, explaining each specification for what would become the SCR-300. He finished by saying something that burned itself into the memories of both engineers. Words they would remember for the rest of their lives. "Henry and Andy, I want you to start working on this immediately. During my visit to the Signal Corps last week, they placed a life and death priority on this program for the infantry. Asterisk, you will get whatever assistance you need. And I expect to see a prototype fabricated as soon as possible." Shocked by the urgency and the weight of responsibility he had placed on them, Mignowski and Affronti read and reread that single sheet of paper several times, absorbing every detail. The Signal Corps designated this communications equipment as a portable infantry battalion transceiver nomenclatured SCR-300. This was a specification document to design and develop a portable frequency-modulated radio, receiver and transmitter powered by batteries. The complete equipment should not weigh over 35 pounds and be carried on the back of an infantry combat soldier. It should provide solid communications over a distance of 3 miles and be waterproofed against rain. No more than 2 crystals could be used, and it should cover a frequency range continuously variable from 40.0 to 48.00 mega. The scope of the challenge was extraordinary, but so was the opportunity. If they succeeded, they would give American soldiers a communications capability no army in the world had ever possessed. Working furiously against time and driven by the knowledge that soldiers' lives would depend on their success or failure, Noble's brilliant team developed a design that was revolutionary in multiple ways. They created a single tuning control that would tune both the transmitter and the receiver simultaneously, eliminating the need for soldiers to adjust separate controls for transmission and reception. This seemingly simple feature was actually quite sophisticated technically, but it made the radio dramatically easier to operate under stress. They incorporated automatic frequency control circuitry that would lock onto the correct frequency and maintain it without drift, ensuring clear communication without requiring precision tuning on the part of the operator. This was crucial because combat soldiers couldn't be expected to have the training or the time or the steady hands to fine-tune radio circuits while under fire or while moving through difficult terrain. They solved the challenging power supply problem by designing circuits that could operate efficiently on battery power while still delivering adequate transmitter output power and receiver sensitivity. Battery technology in 1940 was primitive by modern standards and getting enough power for reliable radio operation without making the batteries so heavy that the entire radio exceeded its weight. Specification required careful circuit design and component selection. They addressed the fungiciding requirement, treating components with special coatings so the radio could withstand the tropical temperatures and humidity of the Pacific Theater where much of the war would eventually be fought. And they managed to do all of this while keeping the total weight at or below the 35-pound specification, though the final production version would end up slightly heavier with the full battery pack. The 300 Seychelles rupees design that emerged from their intensive development effort was an 18-tube battery-operated VHF battlefield radio using FM transmission. The transmitter section and the double superheterodyne receiver were both designed around FM technology, taking full advantage of FM's noise rejection characteristics and its ability to provide clear audio even at the limits of range. The radio incorporated an adjustable squelch circuit, a feature that was new to military radios and would prove to be a tremendous operational advantage. With AM radios, operators had to listen to constant hissing, crackling noise whenever no one was transmitting. This constant noise was mentally fatiguing and made it easy to miss the beginning of an incoming transmission. The squelch circuit silenced the receiver when no signal was present, saving operators from mental fatigue and making it immediately obvious when a transmission came through. The sudden break of silence commanded attention in a way that a slight change in noise level never could. The automatic frequency control circuit ensured frequency stability across all channels without requiring constant operator adjustment. The crystal-controlled calibration circuit allowed operators to verify their frequency setting easily, ensuring that units on the same channel were actually tuned to exactly the same frequency. The tuning mechanism was elegantly simple from the operator's perspective, with a single control knob and a channel display showing channels 0 through 40, providing 41 channels total across the 40 to 48 MHz range with 200 kHz spacing between channels. To frequency control, crystals operating on harmonics provided calibration reference points that allowed the variable tuning mechanism to cover all 41 channels accurately. This was an elegant solution to the two-crystal limitation, using harmonic relationships and careful frequency synthesis to generate all the frequencies needed from just two crystal references. The entire radio could be set up for relay or retransmission operation, allowing to SCR 300 units to extend communications range far beyond line of sight. One radio would receive a transmission and automatically retransmit it, effectively doubling or tripling the communication range without requiring the operators to do anything more than set a switch. This relay capability would prove invaluable in mountainous terrain or in situations where headquarters needed to maintain contact with forward units that were beyond direct radio range. By spring 1942, McNusky, Affronti, and the rest of the engineering team had two working prototypes ready for testing. The prototypes represented more than a year of intensive engineering work. Countless late nights, numerous dead ends and false starts, and the kind of focused problem-solving that characterized American engineering at its best during the war years. On a bright spring day at Fort Knox, the moment came that would prove whether Noble's advocacy for FM technology and his team's year of intense development work had been justified. McNusky and Affronti stood 8 miles apart, far more than the 3 meters operational range specification the Army had demanded. McNusky, standing on the flat roof of the Tropic Air building with his prototype radio, keyed the transmit button and spoke into the handset. 8 miles away, far beyond the specified range, Affronti heard the transmission with perfect clarity. They tested and retested varying frequencies, checking different channels, trying the radios in different locations and orientations. The prototypes performed flawlessly every time, demonstrating range that far exceeded the Army's requirements. When Signal Corps representatives arrived just days later for their formal evaluation, they witnessed demonstrations that impressed them enough to give immediate approval to proceed with production development. Further development and refinement led to the production version of the radio designated BC-11000. This radio unit combined with all required accessories including the battery pack, carrying harness, antenna, and handset comprised the complete SCR 300 walkie-talkie system. The final weight came in at approximately 38 pounds with the larger BA-70 battery or 32 pounds with the smaller BA-80 battery. This was slightly over the original 35 specification, but the Army accepted the additional weight as a reasonable trade-off for the radio's exceptional performance and reliability. For the Army's final acceptance tests before authorizing full production, the production 300 Seychelles rupees traveled to Fort Knox, Kentucky, home of the Armored Force School. There, in the woods and fields and rolling hills surrounding the base, the radio unit underwent comprehensive and rigorous trials designed to verify every aspect of its performance characteristics. ruggedness under field conditions, and usability by soldiers with typical training levels. The Infantry Board, an organization known throughout the Army for being highly critical of communications equipment and skeptical of manufacturers' claims, had been invited as observers. The Infantry Board had rejected numerous pieces of equipment over the years, and their approval carried significant weight. Bob Galvin, son of company founder Paul Galvin, accompanied Dan Noble and Bill Vogel to Fort Knox for these critical tests. The stakes were extraordinarily high. They had only to working production models, and if anything went wrong during the testing, if the radios failed to perform as promised, the entire program could be jeopardized. Each night during the testing period, the team returned to their hotel and carefully checked over both radios, inspecting every component and connection, ensuring they would be ready for the next day's tests. The performance of the 300 Seychelles rupees during those Fort Knox trials exceeded everyone's expectations, even Noble's. The radio communicated clearly through interfering ignition noise from vehicles, proving in practical field conditions that FM's theoretical resistance to electrical interference translated into real operational advantages. The radio continued to function after being subjected to rough handling, drops, exposure to rain, and the kinds of abuse that military equipment inevitably receives in field use. The rugged quality of the mechanical and electrical design was evident in how well the radios held up under conditions that would have destroyed more delicate equipment. The Infantry Board officers, who had seen countless pieces of communications equipment fail to live up to manufacturers' promises and marketing claims, responded with unusual and uncharacteristic enthusiasm. This radio actually worked as advertised. It worked in conditions that would have rendered AM radios nearly useless. It was robust enough for field service. It was simple enough for soldiers to operate. The Infantry Board gave their approval, which carried more weight than any amount of laboratory testing could have provided. The Signal Corps placed orders for production. Galvin Manufacturing Corporation, which would officially change its corporate name to Motorola in 1947, would go on to produce nearly 50,000 SCR-300 units during the course of the war. The first production units coming off the assembly line were rushed by air transport for use by Allied forces in combat theaters. The military placed such extraordinary urgency on fielding the 300 Seychelles rupees because communications problems in the North African and Sicilian campaigns had been severe and had directly impacted combat operations. Message delivery had failed at critical moments, leaving commanders operating blindly. Units couldn't coordinate attacks effectively. Artillery support couldn't be adjusted in real time because forward observers couldn't maintain reliable communications with their firing batteries. These communications failures had cost lives and degraded combat effectiveness. August 1943. The volcanic island of New Georgia and the Solomon Islands became the scene of bitter fighting as American forces pushed forward in their island-hopping campaign across the Pacific toward Japan. The 300 Seychelles rupees made its combat debut here in the Pacific Theater, arriving in time to support operations in some of the most challenging communications terrain imaginable. Colonel Ankenbrandt, the theater signal officer responsible for communications throughout the Pacific, evaluated the new radios under actual jungle combat conditions. Initially, he had been deeply skeptical about the SCR-300's suitability for Pacific operations. Earlier in 1943, when informed that the SCR-511 radio was being replaced by the 300 Seychelles rupees, Ankenbrandt had actually protested the decision to his superiors. He believed that VHF radios like the SCR-300 would not work well in dense jungle operations. His skepticism was based on sound technical reasoning. The tropical environment was brutal on electronic equipment. The thick vegetation of jungle terrain absorbed and scattered radio waves. The mountainous terrain of most Pacific islands created radio shadows and dead zones. All of these factors seem to argue strongly against VHF operation and in favor of lower frequency radios with longer wavelengths that could propagate more effectively through obstacles. But when the 300 Seychelles rupees arrived in quantity and troops began using it in actual combat operations, Ankenbrandt changed his assessment completely. The FM radio's performance in jungle conditions surprised everyone, including the skeptical signal officer. By January 1944, after several months of combat use, Ankenbrandt was writing enthusiastic reports to General Meade stating, "The SCR-300 sets have now been in action in the Tokina area, Bougainville in the hands of the 37th and American Divisions, and I have a preliminary report on them indicating that they are exactly what is needed for frontline communications in this theater." The phrase "exactly what is needed" coming from a skeptical signal officer who had initially opposed the radio's introduction represented powerful vindication of Noble's technical choices and his team's engineering work. Ankenbrandt noted in his reports that the chief difficulty from an operational perspective was keeping the radios supplied with fresh batteries. The BA-70 and BA-80 batteries that powered the 300 Seychelles rupees had limited operational life under the high-temperature, high-humidity conditions of the Pacific. And in the high-tempo operations of jungle warfare, batteries drained more quickly than they did in temperate climates. But that was fundamentally a logistics and supply problem, not a fundamental flaw in the radio design itself. The communications capability the 300 Seychelles rupees provided was exactly what frontline commanders needed to control their units effectively in the confused close quarters fighting of jungle warfare. Second Lieutenant Joseph Dooley, communications officer of the 298th Infantry Regiment, provided detailed operational feedback from the soldiers who actually carried the radios in combat and used them under fire. The main complaint that came up repeatedly in after-action reports concerned the harness design. The weight distribution of the standard harness placed too much of the load too low on the operator's back, which caused significant fatigue during long marches through difficult jungle terrain. The belt carrier brackets had a tendency to jab the operator in the kidneys during movement, which was painful and added to fatigue. These were legitimate comfort and ergonomics issues that could be and eventually were addressed with improved harness designs, but they didn't diminish the tactical value of the radio itself. Despite these minor complaints about the carrying system, Dooley concluded his formal report by calling the SCR-300 an infantryman's dream for better communication and control of troops by radio than ever before given us. That phrase, an infantryman's dream, coming from a junior officer who had led infantry soldiers in jungle combat, and who understood their needs and challenges intimately, represented exactly the kind of endorsement that Noble and his team had hoped to earn. The radio worked in the field. It worked under fire. It gave infantry commanders a capability they had never had before. The tropical environment of the Pacific created unique challenges for all electronic equipment, not just radios. Earlier versions of the SCR-536 Handy had failed catastrophically and rapidly in jungle conditions, with some units lasting only 36 hours before corrosion, humidity, and fungus growth rendered them completely inoperative. These failures had been so severe and so rapid that they threatened to leave entire units without any radio communications capability at all. The Signal Corps had responded by developing specialized tropicalization treatments, including special fungus-inhibiting shellac coatings that were carefully applied to components and then baked on at controlled temperatures to ensure proper adhesion and coverage. These treatments were applied to all radios and electronic equipment being sent to the Pacific Theater. The tropicalized SCR-300 sets proved dramatically more resistant to the harsh tropical environment than earlier radio designs had been. Instead of failing within days, the tropicalized 300 Seychelles rupees radios lasted through extended operations lasting weeks or months, requiring only normal maintenance and battery replacement. This durability under extremely Adverse environmental conditions demonstrated the fundamental soundness of the engineering design and the effectiveness of the tropicalization treatments that had been developed specifically to address Pacific theater requirements. September 1943, the invasion of the Italian mainland began with American and British forces storming ashore at Salerno and Calabria, opening up a new front in Europe and beginning the long, costly campaign up the Italian peninsula. The SC-300 saw its first use in the European theater. During these operations, radio operators waded through the surf with a 32 to 38 pounds radio strapped to their backs, hit the beach under German artillery and machine gun fire, and immediately began establishing communications networks even as the battle raged around them. In the first chaotic hours and days of the invasion, when units were scattered and disorganized, when commanders were trying to establish control and coordinate actions, the value of the 300 Seychelles rupees became dramatically apparent. Company commanders could talk directly to battalion headquarters that might be several miles to the rear, either still on ships offshore or at temporary headquarters established just off the beach. As companies advanced inland against German resistance, they maintained contact even when terrain features like hills and ridges blocked direct line of sight. This was a revelation for commanders who were accustomed to losing communications as soon as units moved any significant distance or moved behind terrain features, forward observers. Some of the first soldiers to receive the 300 Seychelles rupees in significant numbers could now call for artillery fire with unprecedented reliability and speed. Artillery spotters would climb to observation posts, sometimes several miles from their firing batteries, and watch for enemy positions, movements, and concentrations. When they spotted targets, they could immediately radio precise coordinates back to the fire direction centers. The batteries would fire their missions and the observers would watch the shells impact, then radio back precise corrections for subsequent salvos. This observe-adjust fire cycle fundamental to effective artillery support depended absolutely on reliable communications between the observer and the firing battery. Previously, this critical communications link had been frustratingly unreliable with AM radios. Static and interference would cause observers to lose contact at crucial moments. Transmissions would be garbled and unintelligible, requiring multiple repetitions that wasted precious time. Observers would sometimes watch enemy forces moving into perfect target areas and be completely unable to call and fire because their radios simply wouldn't work reliably at the required range or in the electromagnetic environment of active combat. The SCR-300 fundamentally changed this situation. The FM signal cut through the electrical noise and interference that was inevitable on a battlefield. The clarity was such that map coordinates could be transmitted and confirmed without repetition or confusion. Fire missions that had once taken many minutes to coordinate because of communication difficulties could now be executed swiftly and accurately, often in a fraction of the time. The practical usefulness of the 300 Seychelles rupees and the dependability of its rugged design quickly became apparent to the soldiers using them in combat. The U.S. Army was still experiencing growing pains and learning hard lessons in 1943, when fighting against experienced German forces who had been at war since 1939. American units were learning how to fight a modern combined arms war against a skilled and determined enemy, and that learning process often came at painful cost in casualties and temporary setbacks. In this challenging environment, the instant communication afforded by the 300 Seychelles rupees proved invaluable to frontline soldiers and their commanders at every level. When a unit came under unexpected attack and needed immediate reinforcement to avoid being overrun, the 300 Seychelles rupees allowed company commanders to call for help and have reserve units moving to their assistance within minutes instead of the hours it might take for a runner to carry a message back to battalion headquarters through difficult terrain or under fire. When German counterattacks threatened to overwhelm a defensive position, The 300 Seychelles rupees allowed defenders to call in concentrated artillery barges that could break up the attack before it succeeded in penetrating the defense. The radio was quite literally worth its weight in gold to soldiers whose lives depended on being able to communicate reliably with supporting units and higher headquarters. As production of the SCR-300 continued through 1943 and into 1944, the radios were issued in increasing quantities to other units and other branches of service besides the Army Infantry, the Marine Corps, Army Airborne Units, Army Air Force Ground Controllers, and Navy shore parties all received allocations of the 300 Seychelles rupees. The Marines were particularly enthusiastic about the radio's capabilities. In the Pacific Theater, where dense jungle terrain and mountainous topography made communications notoriously difficult, and where units could become isolated and cut off with terrifying speed, the SCR-300's ability to maintain reliable contact over several miles gave Marine commanders a level of tactical coordination and control capability they had never before possessed in jungle fighting. June 1944, the coast of Normandy, France. Operation Overlord, the largest and most complex amphibious invasion in human history, was underway. Approximately 6,900 vessels of all types carried approximately 156,000 Allied soldiers toward the beaches of Normandy to begin the liberation of Western Europe from Nazi occupation. The armada stretched as far as the eye could see. Among the mountains of equipment loaded onto those landing craft, carefully packed and waterproofed against the salt spray and inevitable immersion, were thousands of 300 Seychelles rupees radios. The lessons learned about the critical importance of reliable battlefield communications in Italy and the Pacific had been thoroughly absorbed by the invasion planners. They ensured that every unit that could benefit from the SCR-300's capabilities received adequate quantities of the radios. As the first waves of infantry hit Omaha Beach, Utah Beach, and the other landing sites in the pre-dawn hours of June 6, 1944, radio operators carrying SCR-300s waded ashore through the surf and across the beaches under withering German artillery, mortar and machine gun fire, with soldiers dying and being wounded all around them. These radio operators had to establish and maintain communications networks that were absolutely critical to the success of the invasion. The difference between the 300 Seychelles rupees and earlier AM radios became immediately and dramatically apparent in the chaos and electromagnetic noise of the invasion beaches. The beaches were scenes of almost indescribable chaos and confusion. Hundreds of vehicles, landing craft with their engines running, tanks, bulldozers, trucks, and other equipment created an electrical environment that generated massive amounts of radio interference. Any AM radio trying to operate in that environment would have been swamped by ignition noise and electrical interference from all the running engines and electrical equipment. The SCR-300's FM signal cut through all of that interference as if it didn't exist, maintaining clear communications when clear communications meant the difference between success and catastrophic failure. Battalion commanders on the beaches could talk directly to regiment commanders who might be on ships offshore or at temporary command posts that had been established just inland from the beach. Artillery forward observers accompanying the assault waves could direct naval gunfire from the massive guns of battleships and cruisers against German strong points and defensive positions, and the communications remained clear and reliable enough to ensure accurate fire missions even in the midst of the battle. As units pushed inland from the beaches through the hedgerow country of Normandy, the 300 Seychelles rupees maintained contact through terrain that would have made communications with AM radios extremely difficult or impossible. One technical feature of the 300 Seychelles rupees that became critically important during the Normandy campaign was the relay or retransmission capability that had been built into the design. SCR-300 units could be set up to automatically relay transmissions between them. effectively extending the communications range well beyond what any single radio could achieve and allowing communications across terrain features that would otherwise block radio signals. In the confused fighting through the bowage, the distinctive Hérault country of Normandy, where fields were separated by thick earthen banks topped with dense vegetation that limited visibility to single fields and created perfect defensive positions. Relay operations allowed regimental headquarters to maintain contact with forward battalions that might be several miles away behind multiple ridge lines and through numerous hedgerows. The technical sophistication of the automatic frequency control and crystal control tuning meant that relay operations worked reliably without requiring constant manual adjustment or skilled operator intervention. The signals remained clear, the frequencies remained stable, and the communications flowed as designed, even when relay stations were being operated by soldiers under fire, who had many other things to worry about besides fine-tuning their radios. Emergency requisitions dated June 21, 1944, just 15 days after D-Day, requested an additional 2 OOCR-300 units to replace combat losses from destroyed or damaged radios and to expand distribution to additional units that had discovered they needed the enhanced communications capability the radio provided. This urgent requisition so soon after the invasion demonstrated the high demand for the 300 Seychelles rupees and the recognition by commanders at all levels that this radio was not a nice-to-have luxury but rather an essential combat multiplier that directly contributed to battlefield success as Allied forces broke out from the Normandy beachhead in late July and early August 1944 and began the rapid advance across France that would carry them to the German border by September. The 300 Seychelles rupees proved its value repeatedly in mobile operations where maintaining communications while on the move was essential. Tank infantry coordination, which was absolutely critical to the success of combined arms operations, required reliable communications between tank commanders and infantry company commanders. Armored spearheads racing ahead needed to stay in contact with following infantry units and with logistics elements bringing up fuel and ammunition. Flank guards screening the advancing columns needed to report enemy movements and potential threats. All of this depended on radios that worked while vehicles were moving, while engines were running, while commanders were trying to make rapid decisions based on fluid tactical situations. The 300 Seychelles rupees delivered this critical capability consistently and reliably. December 1944, the Ardennes forest in Belgium and Luxembourg. The weather was utterly miserable. Sub-freezing temperatures, heavy snow, dense fog, and solid overcast skies that grounded Allied aircraft and eliminated the air superiority that the Allies had enjoyed since Normandy. Through this weather, taking advantage of the conditions that grounded Allied air power, Adolf Hitler launched Operation Wacht Ameren, his last desperate gamble in the West. A massive surprise offensive that would become known to history as the Battle of the Bulge, the German attack achieved complete tactical and operational surprise. German armored and infantry forces smashed through thinly held American defensive lines, creating a dangerous bulge or salient in the Allied front that threatened to reach the Meuse River and potentially split the Allied armies. In the chaos and confusion of the German attack, with units scattered and intermixed, with defensive lines breaking and reforming, with some American units cut off and surrounded, communications became absolutely crucial in determining whether American forces would disintegrate into isolated groups fighting hopeless individual battles or would maintain enough coherence and coordination to organize an effective defense and eventual counterattack. This was where the 300 Seychelles rupees proved its greatest value in the European theater. Units that were cut off or surrounded, units that had lost physical contact with adjacent units and with higher headquarters, could maintain radio contact with battalion and regimental headquarters using the SCR-300. This radio lifeline meant that surrounded units weren't fighting blindly and desperately in isolation. Commanders could coordinate movements, could organize withdrawals to more defensible positions, could establish new defensive lines, and could call for reinforcements and supplies because they could communicate reliably with higher headquarters despite being physically cut off by German penetrations. Artillery forward observers who were among the most critical users of the 300 Seychelles rupees throughout the war could continue to call fire missions even when their observation posts were partially isolated by German advances. The ability to rapidly mass artillery fire on German armored spearheads and infantry formations was very often the critical factor that determined whether a defensive position would hold or would be overrun by the attacking Germans. The 300 Seychelles rupees made it possible to concentrate artillery fire from multiple batteries on critical targets within minutes, creating walls of exploding shells that could stop or at least slow down German attacks. The battles around the town of Bastonia, where the 101st Airborne Division and attached units were completely surrounded by German forces for more than a week, depended absolutely on radio communications to coordinate supply drops from Air Force C-47 transport aircraft, to direct artillery fire from batteries both inside and outside the encirclement, and to maintain contact with the relief forces that were fighting their way through German lines to reach the besieged garrison. Without the reliable communications that the 300 Seychelles rupees provided, the defense of Bastonia would have been vastly more difficult, if not impossible. When the Battle of the Bulge finally ended in late January 1945, with the German offensive decisively defeated, and German forces pushed back to their starting positions with catastrophic losses they could not replace, American commanders and staff officers compiled extensive after-action reports, analyzing what had worked and what hadn't during the desperate fighting. One assessment that appeared repeatedly in these reports and in subsequent historical analyses was that many officers felt the 300 Seychelles rupees walkie-talkie was perhaps the single most useful piece of communications equipment employed in the battle. In the chaos and confusion of the Battle of the Bulge, where units were mixed together across normal organizational boundaries, where defensive lines shifted rapidly from hour to hour, where the fog of war was both literal because of the weather and figurative because of the confused tactical situation, the ability to maintain clear and reliable communications across distances of several miles had been absolutely critical to mounting an effective defense and organizing successful counterattacks. The 300 Seychelles rupees had given American forces a communications capability and a resulting level of command and control that the attacking German forces could not match, and that communications superiority had contributed materially to the American victory. The SCR-300 had given American and Allied forces a communication superiority over their enemies that translated directly into battlefield advantages. German radio communication systems still relied predominantly on AM technology throughout the war. While German engineers had developed some FM equipment late in the war, it was never available in the quantities, never achieved the level of reliability, and never reached the sophisticated level of design that characterized American FM radio production. The Wehrmacht had backpack portable radios that were comparable in concept to the 300 Seychelles rupees, but they were generally larger and heavier than the American radio, less reliable under field conditions, and some models required external power sources or used rechargeable batteries that required access to charging equipment, which was a significant operational limitation in fluid combat situations where units might be cut off from rear area support for extended periods. Japanese forces in the Pacific Theater had backpack radios for infantry communications, but some Japanese radio designs relied on hand-cranked generators that required one soldier to continuously and laboriously crank a generator handle while another soldier operated the radio. This was an extremely cumbersome arrangement that effectively removed soldiers from combat, tiring out the soldier doing the cranking and occupying the attention of the radio operator. The 300 Seychelles rupees, by contrast, was powered by self-contained batteries and could be operated by a single soldier who carried the radio on his back and still had both hands free to use his weapon if necessary. This represented a significant tactical and technical advantage that contributed to overall American and Allied superiority in battlefield communications and command and control. At Gallivan Manufacturing Corporation, which officially adopted the name Motorola in 1947, production of the SCR-300 continued at high volume throughout the war years. The radio was also manufactured under license by several other companies beyond Motorola as production was expanded to meet growing demand, and eventually some production took place in France and Italy under license as those countries were liberated and their industrial capacity was brought into the Allied war effort. The production achievement represented a remarkable feat of wartime industrial mobilization and manufacturing expertise. Each 300 Seychelles rupees contained 18 vacuum tubes of various types, dozens of resistors, capacitors, transformers, and other electronic components, all of which had to be manufactured to exacting military specifications. The radios required precision manufacturing and assembly to ensure that they would function reliably under the harsh conditions of combat use. Each completed radio had to be thoroughly tested before being accepted and shipped to ensure it met all performance specifications. The company and its lenses produced nearly 50,000 of these complex radios during the war, and each one had to work reliably in combat because soldiers' lives depended on it. The engineering team that had made this production possible, that had turned Daniel Noble's vision of an FM portable radio into a combat-proven reality, deserved recognition that extended far beyond the headlines and publicity that typically went to weapons systems and combat leaders. Daniel Noble received the Certificate of Merit from the United States Army for his role in the development of the walkie-talkie. This was a significant honor that recognized civilian contributions to the war effort. In accepting the award, Noble characteristically stressed the major contributions of Henry Mignowski, Bill Vogel, Lloyd Morris, and Marion Bond to the project's success. He went on to say something that revealed his character and his understanding of what military service and sacrifice truly meant. He stated that the development of the walkie-talkie was merely an academic exercise when compared to the contribution of the men on the battlefields, the men who were actually fighting the war. Those words expressing genuine humility and recognition of the infinitely greater sacrifice made by combat soldiers resonated deeply with the soldiers who carried the SCR-300 into battle. Those soldiers understood perfectly well that no piece of equipment, however innovative or well-designed, could substitute for the courage, sacrifice, and blood of the men who closed with and destroyed the enemy. But those same soldiers also understood with equal clarity that good equipment that worked reliably when you needed it, made their incredibly difficult and dangerous job somewhat easier, made their survival more likely, and made victory more certain and less costly. The impact and influence of the 300 Seychelles rupees extended far beyond its immediate tactical applications in World War E. The radio represented a crucial proof of concept for FM technology and military applications that would influence and shape post-war communications development for many decades to come. Major General Roger B. Colton, who had been director of Signal Corps Laboratories in 1938, when the historic and controversial decision was made to employ FM in military radios, clearly recognized the long-term significance of that decision, even while the war was still being fought. In a letter dated June 29, 1944, Edwin Howard Armstrong, the brilliant engineer who had invented FM radio technology, wrote to General Collalton, acknowledging and praising the importance and the courage of his decision to adopt FM for military use. Armstrong called it the most difficult decision of the history of radio which anyone was ever called upon to make. He expressed his sincere hope that when the war was finally over, what Colton's organization and the engineers at companies like Motorola had accomplished in developing and fielding FM military radios could be properly laid before the world, and given the acknowledgement and recognition it deserved. Armstrong had invented frequency modulation technology in 1933 after years of research and experimentation. He had donated free use of all his FM patents to the United States Army during World War II, waiving all royalty payments as his contribution to the war effort. And he had served in an advisory capacity to the Signal Corps on technical matters related to FM radio. However, Armstrong himself was not directly involved in the actual design and development of the SCR-30. That work was done by Noble's engineering team at Motorola, building on Armstrong's fundamental invention and applying it to the specific challenges of portable military radio. The decision to adopt FM for military radios had been genuinely controversial within both military and civilian radio engineering communities. It required the military to move away from familiar proven AM technology that everyone understood and that had been the foundation of radio communications for decades. It required the military to embrace a newer, more complex system that many respected engineers and technical experts claimed was too sophisticated and too difficult to maintain for reliable military use under field conditions. It required substantial investment in new equipment designs, new manufacturing processes and tooling, new training programs for operators and maintenance personnel, and new logistics systems to support a completely different type of radio technology. But the combat results, the performance of the 300 Seychelles rupees and other FM radios under actual battlefield conditions against real enemies proved beyond any possible doubt that the decision to adopt FM had been absolutely correct, despite the controversy and the difficulties. The SCR-30, along with the vehicular FM radios like the SCR-508 and SCR-608 that were developed, in parallel marked the beginning of a fundamental transition in military communications, from AM to FM that would continue through the Korean War, through Vietnam, and into the modern era. Today's military radios, though incomparably more sophisticated with digital signal processing, frequency hopping, encryption, and satellite connectivity, still rely on many of the same fundamental FM principles that Daniel Noble and his team successfully implemented in the SCR-300 more than 8 decades ago. The improvement in communications range and reliability that the 300 Seychelles rupees provided over the earlier SCR-536 handy from approximately 1 mile to 3 miles in typical operational use with up to 5 mi. Achievable in optimal terrain and atmospheric conditions represented far more than just a numerical increase in capability. It represented a fundamental and transformative change in how infantry units and combined arms forces could be commanded, controlled, and coordinated on the battlefield. Before the 300 Seychelles rupees became available, company commanders had to stay relatively close to their battalion headquarters if they wanted to maintain reliable radio communications. This proximity requirement significantly limited tactical flexibility and often meant that commanders weren't positioned where they could best observe the enemy, understand the tactical situation, and effectively direct their units. With the SCR-300 providing reliable communications over 3 miles and sometimes more, a company commander could operate several miles away from battalion headquarters and still maintain continuous radio contact. This extended range allowed for much more aggressive and flexible tactics, for wider envelopments around enemy flanks, for deeper penetrations into enemy territory, all executed with confidence that if reinforcements were urgently needed, if the tactical situation changed dramatically, if higher headquarters needed to issue new orders based on intelligence from other sectors, reliable communications would be maintained throughout. The psychological impact on soldiers of knowing they had reliable communications was also significant and shouldn't be underestimated. knowing that they could call for help if needed, that artillery and air support were just a radio call away, that their higher headquarters knew where they were and what situation they were facing. All of this boosted morale and combat effectiveness in ways that were difficult to quantify but very real. Soldiers who felt isolated, abandoned, and cut off from support fought less effectively and with lower morale than soldiers who knew they were connected to a larger organization that supported them and could come to their aid. The British military, which had pioneered much of military radio technology in the pre-war years and during the war, recognized the superior capabilities of the American 300 Seychelles rupees and began development of their own version during the latter part of World War II, the wireless set number 31, which was similar in design and capability to the American BC 1000 component of the 300 Seychelles rupees system, entered British military service in 1947 to 1948 after testing programs that had begun in 1947. This represented significant acknowledgement from a nation that had been at the forefront of military radio technology development that the American FM portable radio design represented the best approach to infantry communications. The adoption of the SCR 300 design concept by the British and subsequently by other allied nations created important standardization benefits that extended well beyond World War II and became increasingly important as the Cold War developed and the North Atlantic Treaty Organization was formed. Allied forces could share maintenance expertise, training programs, and operational procedures. Communications between forces of different nations were simplified when they used compatible equipment. This interoperability proved valuable in combined operations and in the collective defense arrangements that characterized NATO. The technical and operational legacy of the SCR 300 extended far beyond World War II, continuing through the Korean War and into the Vietnam era. While the basic vacuum tube design of the SCR 300 was eventually superseded by lighter, more capable radios that used transistor technology instead of vacuum tubes, the fundamental concepts and design principles that had been pioneered in the 300 Seychelles rupees remained standard in military portable radios for many decades. The EPRC-10, which replaced the -300 Seychelles rupees in American service during the Korean War era, weighed approximately half as much while providing similar or slightly better communications performance. The highly successful PRC-5 and PRC-77 radio families that served throughout the Vietnam War and for decades afterward, built directly on the same FM principles that the 300 Seychelles rupees had proven in combat, but incorporated solid-state transistor technology that dramatically reduced size, weight, and power consumption while increasing reliability. The story of the 300 Seychelles rupees is ultimately a story about technical courage, about innovation in the face of institutional resistance, and about the willingness to challenge conventional wisdom when you know there's a better way. When Daniel Noble told Major O'Connell in those meetings in Washington that the Army's plan to develop an AM portable radio was a grave mistake, when he forcefully insisted that FM was the right technology for portable military radio despite the Army's clear preference for familiar AM technology, he was taking a very real professional and personal risk. He was contradicting the established preferences of the military procurement system. He was advocating for a more complex and potentially more expensive technological solution when the simpler, cheaper solution seemed adequate. He was asking busy military officers to trust his technical judgment over their own institutional preferences and their organization's established practices. But Noble understood something that many others did not fully grasp at the time. He understood that FM offered genuine fundamental advantages in battlefield communications that would more than justify its additional complexity and cost. He understood that soldiers operating in the electromagnetically hostile environment of modern mechanized warfare needed communications that would work reliably in the presence of massive electrical interference. He understood that clear voice transmission at the limits of range could mean the difference between successful coordination and catastrophic confusion. He was willing to stake his professional reputation on these beliefs, and his willingness to take that risk and fight for what he knew was right paid off in ways that saved countless lives and contributed to winning the war. The engineering team that turned Noble's vision and advocacy into working hardware that solved the enormous technical challenges involved in creating a battery-powered FM portable radio that met all of the Army's demanding specifications demonstrated the kind of focused, urgent, practical innovation that characterized American engineering and industrial mobilization at its finest during World War II. When Noble placed that specification sheet in front of McNusky and Affronti and told them it was a life and death priority for the infantry, he wasn't using hyperbole or exaggerating for dramatic effect. He was stating a literal truth. Soldiers' lives depend on whether this radio worked reliably in combat. The engineering team understood the weight of that responsibility, and they delivered results that exceeded the Army's specifications and expectations. When Daniel Noble and Henry McNusky stood 8 miles apart in those Kentucky fields in the spring of 1942, testing their prototype FM radio and achieving crystal-clear communications far beyond the Army's 3-mile requirement, they knew they had succeeded in creating something technically impressive and important. But neither of them could have fully understood or predicted the enormous scope and scale of that success, the impact their radio would have on the war and on subsequent military communications development. The 300 Seychelles rupees would serve in every theater of World War II where American forces fought. It would be used on the volcanic islands of the Pacific, in the jungles of New Guinea and the Philippines, in the mountains of Italy, in the hedge of Normandy, in the forests of the Ardennes, in the final drive across Germany. It would be carried on the backs of infantry privates slogging through mud and jungle. It would be used by artillery forward observers calling fire missions from exposed observation posts under enemy fire. It would be used by tank commanders coordinating combined arms operations. It would serve with airborne troopers jumping into enemy territory, with Marine raiders hitting hostile beaches, with special operations forces operating behind enemy lines. The 300 Seychelles rupees saved countless lives by enabling timely and accurate artillery fire that broke up enemy attacks before they could succeed. It saved lives by allowing isolated units to call for help and receive reinforcements in time. It saved lives by maintaining the command and control that prevented units from blundering into ambushes or friendly fire situations. It contributed to victory by giving American and Allied forces a decisive advantage in battlefield communications and coordination. After the war ended, the 300 Seychelles rupees served as the foundation and proof of concept for generations of improved military radios that continued to use and refine the FM principles that Noble and his team had successfully proven in combat. Each successive generation of military portable radios built directly on the lessons learned from the 300 Seychelles rupees, incorporating new technologies like transistors and integrated circuits, but retaining the fundamental FM approach to battlefield communications. The improvement in battlefield communications capability that the SCR-300 represented was far more than just a technical achievement to be noted in engineering journals and military equipment catalogs. It was a war-winning advantage that gave American and Allied forces a decisive superiority in their ability to command, control, and coordinate forces on the battlefield. That communications superiority translated directly into tactical and operational advantages that helped defeat the Axis powers and win the war. That decisive advantage came from one engineer's clear technical vision and his courage in advocating for it against institutional resistance, from one brilliant engineering team's successful execution of an enormously challenging development program, and from one company's willingness to embrace innovation and take on difficult challenges even when the outcome was uncertain. The SCR-300 stands as an enduring testament to what technical insight, engineering excellence, and determined innovation can achieve when applied to problems where success literally means the difference between life and death, between victory and defeat. Today, more than 8 decades after those prototype tests in the Kentucky Spring, we still benefit from the legacy of Daniel Noble's revolutionary radio and from his unwavering determination to give American soldiers the very best communications technology that engineering skill and manufacturing capability could provide. The story of the 300 Seychelles rupees reminds us that technical innovation, courage in challenging conventional wisdom, and excellence in execution can change the course of history.